Hello everyone. In this session, I am going to explain about the maximum power transfer theorem. Yes, the maximum power transfer theorem means the name itself is telling the maximum power to transfer, where we have to see in this session. Right? In this session, we have to study about the statement of the maximum power transfer theorem, proof, and the problems we can solve in this session. Right? Statement of the theorem. When the load is connected across the voltage source, when the load, for example, we can take that. When the load is connected across the voltage source, right? This one is a E, we can take it. Voltage source, power is transferred from the one source to the load, from one source to the other load. The amount of the power transferred will be depend upon the load resistance. The load resistance RL is made equal to the internal resistance RI, RL, MFE. Yes, resistance. If the load resistance RL is made equal to the internal resistance RI of the source, then the maximum power is transferred to the load RL. Means what? RI equals to RL we can prove from this theorem. This theorem what it tells in ಹೇಳುತ್ತೆ ಅಂತಂತಂದರೆ ಈ ಥಿಯರಮ್ನಲ್ಲಿ ನಾವು ವೋಲ್ಟೇಜ್ ಸೋರ್ಸನ್ನು ಒಂದು ಇಟ್ಕೋತೀವಿ, ಒಂದು ಇಂಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಮತ್ತು ಒಂದು ಲೋಡ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇಟ್ಕೋತೀವಿ. ಯಾವಾಗ ಇಂಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಈಕ್ವಲ್ಸ್ ಟು load resistance, when it becomes the power is maximum to transfer to the load, this is known as the maximum power transfer theorem. You also can define by the maximum power is. The maximum power is transferred from the source to the load. When the load resistance is made equal to the internal resistance of the source. Yes, this is the maximum power theorem. When by the graph we can draw it, when the RL in the one section and the P is in the other section, the power it is increasing and reaches the maximum, then it starts decreasing. This is a P max. Power is maximum. It is called as a maximum power transfer theorem. Right. What we have to define to prove this theorem mathematically, considered a voltage source, generated a voltage, internal resistance and delivering the power to the load resistance RL. Means that we have to draw the circuit. Yes, this one is your voltage source. The current is moving in this direction. Yes, the current comes like that. Yes, this one is your EMF source. This one is a load resistance. Correct. When I equals to V by R by the Ohm's law, now we can tell I equals to E divided by RL plus RI anta bariboda. Yes, correct. RL plus RI. Correct. Now, power equals to normally I square into R anta ತಗೊಳ್ತೀವಿ ಗೊತ್ತಾ? Correct? Can we take it or not? Yes, taken. The I equals to E divided by RL plus Ri square. RL plus Ri square. Right? Then RL is a, make it same. Right? For the given source generated the voltage, for the given source generated the voltage, right? E is internal resistance Ri are constant. If the Ri is a constant, Ri is constant, right? That is the, makes that one, it is the, to using this theorem, therefore the power delivered to the load depends upon the RL. In order to find the value of RL, which value of the P is maximum, differentiate the equation 1. This one is your equation 1. Differentiate. dP by dL with respect to RL, dP by dRL equals to the square, it is the E square. Next, what we have to find? This is the denominator, RL plus Ri square minus 2 into RL plus Ri divided by RL plus Ri whole raised to 4 by this differentiation method. Right. Next, what we have to simplify this equation, RL plus Ri square minus 2RL plus Ri equals to 0. Right? This one is equal to, we can take it, we can get R1 and R1. RL plus Ri equals to 2RL. Yes, 1 RL get cancelled. Ri equals to RL. We have proved by this equation, by the differentiation method we can derive the maximum power transfer theorem. And we are going to study about the problems on the maximum power transfer theorem. Shall we move for that one? Yes, this is your problem number 1, to find the power of output by using the maximum power transfer theorem. They have given the value of the RL equals to 15 ohm. This signal generator galvanometer, it is 12 volt. Right. Next, Ri is 15 ohm. Current is moving in this direction and in this direction. Yes, this is a 15 volt. Yes. Next, we have to find out the theorem. Load resistance RL equals to 15 ohm. Ri equals to 15 ohm. Right. Ri equals to 15 volt. The circuit current I equals to what we have to write that one, V divided by RT. RT equals to Ri plus RL. Right. V equals to how much? 12 volt divided by 15 plus 15, 30.4 ampere of the current. that is your I, that is your circuit current. This is the overall circuit current is I. The next power equals to I square into RL. I square is 0.4 square into load resistance, how much? 15. 1.6 into 15. 14 point, just a minute, 44 square into 15. It is a 14 into 0.016. We can get it in the 2.4 watt of power. It is a P max. We can find out by this equation. Next problem, we can take it for the problem number 2. It is a resistance, inductance and the battery they have given. It is a AC source, 50 volt. Yes, 50 volt, 100 ohm and 50 ohm they have given, with the RL equals to 100 ohm. That is, your current is moving in this direction. Now we can find out by the AC. We can take the ZL is a impedance, 100 minus 50J ohm they have given, right? J50 means this one is a inductance we can use. Total impedance equals to ZT equals to ZI plus ZL. ZI internal, how much they have given? 100 plus minus plus J50 plus 100 minus J50. You can get it in the 200 ohm. Have you given? It is a total impedances and the circuit current equals to I equals to V divided by ZT. They have given the V is 50 volt, right? 50 volt. RI is 100, 200. You have got it. Total impedance plus RL is total RL we have find out 0.25 ampere of current they have used, right? Then it is a maximum power transfer to the load equals to I square RL. I square is 0.25 square into 100 equals to 6.25 and watt. It is in the power. It is in a watt. These are the two examples we can use in the maximum power transfer theorem. Yes, in the next session we are going to study about the reciprocity theorem. Okay, thank you once again. You have to practice the more and more problems. You can get some knowledge about the theorems easily. Okay, thank you friends. Thank you.